So mixed exercise 7, question 7, and we've got this situation. We've got sin x is 2/5, cos y is 2 over root 5, cos y is 3 over root 10, and x and y are acute angles. Show that cos 2x equals minus 3/5. Now the key here, sorry, it's wrong as well, isn't it? Yeah, no, it is minus 3/5. Show that x and y are acute. That's where all the information is, I think, well, at least the way I'd think about this question. If x is an acute angle, then we can draw it in a right angle triangle. So these sides here, the opposite and the hypotenuse, are in the ratio 2 to root 5. So we may as well write them in as 2 and root 5. We don't know what the units are, but 2 to root 5. Pythagoras theorem, then I'll tell us this one. So root 5 squared is 5. Take away take away 2 squared, which is 5, take away 4, which is 1. So cos of x is 1 over root 5. So we know sin x, we know cos x. Cos 2x is cos squared x minus sin squared x. So that is, cos squared is 1/5. Sin squared x is 4/5. So that gives us minus 3/5, which is what we were looking for. The second part is asking for the value of cos 2y. So same thing, if I draw angle y, 3 and root 10 are these things here. So that would make this a length 1 again by Pythagoras theorem. Root 10 squared is 10, 3 squared is 9, 10 take away 9 is 1. So sine of y is 1 over root 10. And then what do we need to do? Cos 2y is what we're trying to find. So cos 2y is cos squared y minus sine squared y, which is 9 over 10 minus 1 over 10, so 8/10, which is, I hope, the answer in the back of the book. I haven't checked. Hopefully it is. Show without using your calculator, so tan x plus y is 7, and x minus y is going to be pi by 4. So let me see, tan x plus y. It occurs to me that probably the best thing to do, I'm just looking at this trying to see if there's a quicker way of doing it. The first thing that springs to mind is this. Tan x plus y, we have a formula for tan x plus y, and so if I use that, it will give me things in terms of tan x and tan y. So that is tan x plus tan y over 1 minus tan x tan y. So I could do it from here by tan x is sin x over cos x, this is sin y over cos y, and I can work out everything I need, because I know sin x, I know cos x, I know sin y, I know cos y. I suppose it would be slightly easier if here I just did sin x over cos x. Oh, actually, I can, silly me, I can work quicker than this, can't I? Tan x is 2, and tan y is 1/3. So there we go. That's the quick way to do it. So tan x is 2. Tan y is 1/3. So I can work from there. So that would make this 2 plus 1/3 over 1 minus 2/3, which is going to be 2 and 1/3. And I'm carrying on from here because I think it's going to be helpful for the last part of the question. 1 minus 2/3 is 1/3. So 2 and 1/3 is 7/3 over 1/3. So that's 7. Tan of x plus y is 7. That seems a bit odd. I feel like I've made a mistake somewhere there. No, that's what we're looking for. So tan of x plus y equals 7, which of course doesn't help us at all with the next bit. So tan of x minus y. Well, so the next thing they're asking for is x minus y. Well, let's think of this as tan of x minus y. Tan of x minus y is tan x minus tan y You'll notice the sound of me flicking backwards here because I always have to just double check these formulas. There we go. If you're heading to an exam, you obviously need to have these memorised. Tan x minus tan y over 1 plus tan x tan y. So I'm feeling like this might be the right thing to look at. I don't know yet if I'm right. I don't know if this is going to work, but let's try this. The question is asking us, this is 7c part 2, what's the value of x minus y? Well, tan x we know is 2. Tan y we know is a third. 1 plus 2 thirds, 2 times a third. So 2 minus a third is 1 and 2 thirds, so it's 5 thirds over 1 plus 2 thirds, so that's 5 thirds. In other words, 5 thirds divided by 5 thirds, well, that's 1. Okay, so what I've got is tan of x plus y is equal to 1. Well, if tan of x plus y is equal to 1, then this angle here must be 45 degrees because tan of 45 degrees is equal to 1. And 45 degrees is pi by 4. So x minus y must be pi by 4. You could say, well, what about there are other values? Tan of something is equal to pi by tan of something is equal to 1 doesn't necessarily mean 45 degrees, but I know that x and y are both acute angles. And I suppose so therefore I'm going to either have a positive or a negative acute angle. If you think about it, if you're doing two acute angles, one take away the other, then the smallest you could get is minus 90 degrees, isn't it? And the biggest you get is 90 degrees. So the x minus y has to be in the interval minus pi by 2 to pi by 2. X minus y has got to be in that interval there. But if you look in that interval, then there's only... if we know that x minus y is in that interval and that it's 1, then it has to be positive pi by 4 because there's no positive values of tan of a negative number which is bigger than pi by 2. So there we go. That's the whole of question 7.